streaming. Awesome. And at the same time, we're just going to go live here on recording.
It's like with your picture. You count to 3. You don't stop at 2. You don't go to 4. You stop at 3.
Right?
From 1, 2, 3. Stop there.
Okay, there we go.
3.
Welcome back. We are MDEV1004 in the summer 2023 semester at Georgian, and it's week 2, part 2 of our broadcast and recording. And the last part what we did was we talked about the assignments. The first assignment 1, it's due in, we're sitting at week 2, it's due 3 short weeks from now on week 5, June 11th, but plenty of time. I think this assignment you can probably knock off. I'm giving you 7.5% for this assignment. You can probably knock it off, I would say, within a couple hours. I would say tops if you're diligent. 3 if you're having some issues, right? With you and your partner, maybe some overhead. 4, would be probably tops if I was going to stretch it, right? Because you and your partner have to talk and blah blah and whatever, what your favorite movie list is. But that's how I see it. So now we're going to talk about just a bit of a JavaScript review. This is going to be a bit of lecture-y stuff. I'm going to try and skip through the stuff that you should already know. And one thing I mentioned last week, which I'll mention again this week, is although there's like tons of slides here, I've got 85 slides. I am not going to read these 85 slides. I'm going to talk about them, and I'll skip stuff. It's for your reference, because there is no textbook for this course. I don't include textbooks in my courses unless I really need them, or if there's a lot of heavy material that I can't cover. For example, if I'm teaching you, AI for gameplay, right? There's a whole book, that you need to learn, and I can't possibly teach every single thing about AI, so then I include the book as a reference. But otherwise, everything I've distilled is all in your, everything you need is here distilled in your PowerPoint slides. And so you don't need anything more, but that means that these aren't presentation slides, these are teaching slides, these are reference slides. So ECMAScript 2015, remember we talked about this briefly. ECMAScript is the foundation of JavaScript. My friend Jeremy, who just came in, he was like, JavaScript sucks, I hate JavaScript. And I'm kind of the other way around. I think PHP is terrible. That's just me. I mentioned here on the video, so if you watch this video, that's what I think. I think, PHP is not what I prefer to program in on the back end, but JavaScript is. And way back in 2015, we had this revolution with the, V8 engine that Google put out. This is the history. You guys should know about this already, yeah? No? No, good. Okay, so Google, 2007, 2008 timeframe, they put out this V8 version of their Chrome engine, right? And the V8 version of the Chrome engine was so fast that people were so happy with it compared to the previous versions. They're like, wow, this is actually a workable app now, right? We can actually surf, and it feels good. Surf was actually a word back then. Now we just ignore that. That's for old people. Anyway, so then what happened was, around the same time, there was this push for better JavaScript. JavaScript, at the time, people were right. It was pretty tough to work with. I'm not going to use the S word. I'm not going to say it sucked. It didn't suck for me, right? But for some people, they couldn't stand JavaScript at the time. They were really unhappy with it. And they wanted changes. So ECMAScript is an organization, ECMA. And ECMAScript isn't just for JavaScript. ECMAScript and the ECMA organization, if you actually look up ECMA, right, as an example, and it's not these guys. If I go ECMAScript, ECMAScript, right, it's ECMA International, these guys, right? And ECMA International is actually a foundational model and governing body, if you will, or a committee that basically creates standards for all general purpose programming languages based on the ECMA standard, which isn't just JavaScript. It's also Java. It's also other programming languages, right? And so what they've tried to do is they've tried to improve and push the standards forward by adding additional functionality to JavaScript. And they keep doing that every single year. This is not something that stops. That's why I said at the beginning of this semester, web development is probably one of the hardest things you can do. And the reason why is because it constantly is shifting and changing and everything else. So ECMAScript 5 was the big jump, and that was in 2015, right? Where we moved from ECMAScript, jump back. ECMAScript 5 was before 2015, and it was a pretty good version of JavaScript. Still semantically heavy, lots of curly braces. We saw the iffy in it a lot, right? And the module pattern that they used, it was kind of clunky, right? So that's what they had. And we had to move to something more, performant, and so and with more features, and so ECMAScript 6 came along. ECMAScript 6 at one point, when it came to writing functions and classes, especially classes, people had the idea that you could write classes in JavaScript, and they were object-oriented the same as they would be in C# or C++ or Java, and the answer is they're not. JavaScript is a prototypal language, so prototypes. That's the basis of all classes in JavaScript, and it's not a classical kind of language. Like, it doesn't use classical inheritance. It uses prototypal inheritance, which is a complete different way of doing things, more functional programming-wise than object-oriented programming. And so back in the day, whenever we wanted to make a class, so-called, right, we made a function, and we made a function in a function. That was a class, right? And what that looked like, just as a bit of a history, if I went to typescriptlang.org again, and I think this is a great little playground, if I can actually get to there today for some reason. Who knows? Maybe it's blocked, right? Or it's down. Oh my God, right? Maybe it's down. Maybe typescriptlang.org is not working anymore. Let's try other sites, like, I don't know, Steam. Oh yeah, we're up in the internet. The internet's going because that's working, but somehow typescriptlang.org is down. But the great thing is about it, yeah, it's going to go down again. So maybe they're undergoing some maintenance, these guys. But one thing that we can say is when we look at ECMAScript 5, if I was to look at ECMAScript 5 classes, right? If I looked at ECMAScript 5 class, and if I wanted to get an example of that, like what does that look like? And if I said ECMAScript 5 class example, right? What does that look like compared to, ECMAScript 6? There's plenty of sites out there that'll show you the difference. And there's a couple ways to do that. So here are this object.prototype.keys, object.prototype.whatever. You use the object superclass or the object super duper thing that exists in JavaScript. I'll put it that way. Every programming language has a super duper duper version of their base class for all other classes, right? And in JavaScript, it's the object superclass, right? And so it's the same thing for other languages as well. With C# also has the object superclass, and so does Java, right? And so this object superclass is like the superclass of all superclasses, right? That's what it is. And this is how you did it. So we say object.prototype. In old school JavaScript, you never had to really define the property. As long as you assign it, it's defined. There is no var or let or any of that stuff required. If I say something like object.tom is equal to 25, Tom suddenly exists. Never existed before, but as soon as I assign value to Tom, Tom is suddenly a property, right? And that was really frustrating for people because they were like, wait, that can't be the way it is. There's also something called JavaScript object notation, not JSON, but actually object notation like this. User is actually an object. So instead of having a class, you would have this object-based class, right? Or object-based, kind of definition of a user. The problem is with this is there's no schema. It's schemaless, right? Which is positive and negative, right? So where classes looked like classes, they look like have a constructor and you had, functions and all this kind of stuff. And that's what we moved into. We moved from this idea of, this old school ECMAScript 5 function-based classes where we had functions within a function to create a class, where the outside function, call it the closure or whatever, that outside function was actually the constructor, right? And the inside function other functions inside of them. Sorry, the outside function was the class name, the inside class was the constructor, and then what you'd have is every other function, you would have to have something like whatever the name of the class was. Let's say, for example, person was the name of the class. You would say person dot, prototype dot, and then whatever the name of the function that you wanted to add equals to an anonymous function, and that would be your function. Like, it was really cumbersome, right? So we wanted to move away from that and actually have a lot easier syntax. And so ECMAScript 6, which is what it was called at the time, was born. And it kind of created all kinds of lovely things that we had that it kind of built in with all kinds of additional things that we didn't have in ECMAScript 5. We moved away from calling it ECMAScript 6, although it's still called that in some circles. But now we called it ECMAScript 2015, 2016, whatever the year is. This year's 2023. There's ECMAScript 2023. The standard is there, and it's going to be ratified in July of every year. So this year, July of 2023, the ECMAScript 2023 standard will be ratified, right? Whatever that's given. So they're going to add more features to it. Okay, so that's the thing. So one thing that they added was this difference in module pattern. Ever since 2015 and up, whenever we talk modules, the ECMAScript module pattern, right, is the one we want to use for, for Node. But one thing that if you try to use the ECMAScript module pattern, ESM, or the ECMAScript 2015 module pattern in just regular HTML, it'll fail, even now. You have to add this keyword to your HTML file, which is type is equal to module, and in order for it, and this is on the script declaration, in order for you to know that this is a module, this thing is a module, and still very clunky, right? To be honest. So remember, whenever you think about does it work, you can always go to caniuse.com. I'm not sure if you guys know caniuse.com, but caniuse.com allows you to search anything that exists in JavaScript. If I say something like module, then you can look at things like dynamic modules, which is a different thing, a dynamic import, the CSS Flexbox layout module, JavaScript modules via the script tag. Now this is what we're talking about, where type is equal to module, and it tells you right there. And it basically tells you which browser is supported. This is a great little site, as well as globally how much support you have for a feature. So in this case, 96% support for the module pattern. But only several years ago, this was a much lower number. If you get lower than, in my opinion, 90%, you shouldn't use that feature. That means like there's 10% of people that aren't going to be able to do it out there. You might have a feature that you really love, you want to try this thing out. It doesn't work for 1 out of every 10 people. It doesn't work. That's bad, right? It's got to be higher than that. It's got to be like in this kind of take. And a lot of the older browsers that we had here, like Internet Explorer, you can see that still don't support this feature, right? Because Internet Explorer is deprecated, but yet people still use it, right? People still use Internet Explorer on some older systems because there are enterprises out there who have a lot of tech debt, and they have a lot of grandfathered systems that are just sitting there working, and they don't want to spend any money, right, to upgrade any of them, not their operating system, definitely not Internet Explorer or anything like that, just sitting there. And so somewhere out there, there's stuff out there that is still being used. And that's why we put these things together. But you can see like all the latest versions of Chrome, or even Edge, which I don't like, Safari or Firefox, those are the big ones. Opera, poor Opera, who uses that anymore, right? And other ones, those major ones all support it, and the latest versions, so you're pretty good to go. For many, many versions. You can see like version 61 to 112. Like it's like a lot of versions that support it. So that's one thing you can look at. And so front end wise, if I look at the front end, then this is pretty good. This is pretty supported. And what we do is we use imports and exports. And what we do is we say something like, well, I want to export this function. I want to export this variable. I want to import this module, right? And this is the difference between imports and exports, right? So if I go back, let's suppose I have a file named lib.js. This is a regular thing. This has nothing to do with Node. And lib.js, a library, has a function that takes half of whatever you put into it, right? So half of x, right? So I take x divided by 2, and that's what you get, whatever it is, right? And then what you do is in your main.js, you do something like import half of from lib. So half of is the name of the module, not the function, right? Even though the name is, this is where it's a little bit, people get it wrong. It's not that I'm doing this. I'm exporting this function, and this function is going to be, think about it, each file as a container, right? And when I do an export, I'm exporting the entire container, not just one function, right? However, in this case, I've specifically said that I want to export this function. And because I'm exporting this function, it's assuming that the entire container is a reference to the function itself, the whole container, the whole file. So therefore, this works, this part here, if import half of from lib, where lib is lib.js, right? Notice that there is no .js at the end. That's just normal, right? But half of refers to the container. But in this case, the whole container is a function. So yeah, this would work. But the container could also have other exports, right? So just keep that in mind. And so this module pattern was something that came along. And here's an example of where what's something that's different for lib.js than it is for Node.js. If I do export function, now I have two functions, right? Half of and multiply. As soon as I do that, the module now isn't just a container, but I want you to think about it as an object, like that object notation object with curly braces object, that contains two functions, right? Half of and multiply. That's what it does. And then when I import half of and multiply from lib, right, then I can use those two function names the exact same way. All right, that's how it works. It's kind of a weird way of doing things. And this basis is what we do in Node. With Node, we do the exact same thing. We use exports and imports and all that kind of stuff in Node. And we're going to talk about this a little bit more. But that's how it works. So again, ECMAScript also has something called a default export, where if you have a default export, that represents the entire container. And then if you did other things, other exports, it would ignore them. Export default is what we're going to be using a lot for our modules in Node. All right? You're going to see that. Okay, I'm just going to skip here. It talks about other kinds of issues with modules. Classes. Let's do this. Classes. So classes are different. One thing I want you to always think about, this prototype-based inheritance stuff, no matter what you do, right, in TypeScript, no matter what you do in ECMAScript, on the back end, everything is prototypes, not classical inheritance classes. Even though you might think that they're classes, they might act like they're classes. They are not classes like we know them in C# and C++ and Java. They're just not like that at all, right? So one thing that you always to say is in TypeScript, we have types. I can make access modifiers like we do in Java or in C#. What is an access modifier, by the way? If I was going to ask you a question in an interview, what's an access modifier? Anybody? Daryl or Manjit? Do you know what it is? Access modifier is like read and write, but whenever I say access modifier, that means that is an object private or public or protected or whatever. That's what I mean, right? So if an object or property is private, public, or protected, that's the access modifier. We can put that in C# or Java or Kotlin or Swift or whatever, right? Swift actually, why would you do it? Because everything is public in Swift. In Java, everything is public. In C#, everything is private by default, right? And in C++, depending on what you use, if you use a struct in C++, it's public, and if you use a class in C++, it's private by default, right? So these are access modifiers. And we can do the same thing with TypeScript, but in JavaScript, everything is public. Let's think about that for a second. TypeScript is syntactic sugar that's going to be on top of JavaScript to make it easier. And we're going to add typing to JavaScript, kind of. But we transpile back into JavaScript at the end of the day. So guess what? Even though you might say this is private, it's still public. This causes people to not understand. They're like, wait, I marked this as private, but people can still access it. Yes, they can. All you're doing is you're marking it as private, so it gives you an error, right? So that you know you're accessing it in the wrong way. You're going outside of like your standards or your best practices or whatever. For you, it's wrong, right? But back end, it'll work. JavaScript will do anything. You can even assign whatever you want to assign with it. So it gives us things like instance members, static members, constructors, and supers. It also does a lot of other stuff out of the box. ECMAScript, when ECMAScript 2015 came out, it was a revolution. We were happy about it, right? But still, it was missing a lot of stuff. It had a lot of gaps to be filled. And so, therefore, TypeScript was born. Angular was a huge invention back then. Front-end frameworks. We had back-end frameworks like Node and whatever. But we needed some front-end frameworks to work. And AngularJS, not Angular, but AngularJS at the time, they needed some additional support. So Microsoft and Google got together and they said, let's make something together for the first time. And they made TypeScript, right? They made Angular, right? And Microsoft ran with TypeScript. It's a Microsoft thing, TypeScript. It's a Microsoft language. And it's one of the best languages out there right now for to work with the web, in my opinion. And we'll talk about that. So here's some example of classes. You can see that there's a class here, vehicle, and this is what you need. Constructor is a thing. You need to say that it's a constructor. And in other languages, we have some kind of function that's named the same as the class. So for example, in Java, it would be called the vehicle function, which have to be public. In C#, as we have to say public vehicle in C#, and in C++, you'd still call it vehicle, right? And it would be in the public space, public constructor, right? Here in JavaScript, you just say constructor. You don't have to put public next to it. And by the way, JavaScript doesn't have public or private. Remember, like I said, so you just put constructor. Constructor means that this is the constructor function. So this constructor triggers when you're trying to instantiate an object of type vehicle. We use the extends keyword in JavaScript to denote inheritance. That's how we do it. So we say, this car extends vehicle, right? Because vehicle could be any kind of thing. How many wheels does a vehicle have? It could have 2 wheels. It could have 1 wheel, unicycle. It could have 5 wheels. It could have 6 wheels. It could have 18 wheels. We don't know what kind of vehicle it is, or more, right? But a car might only have 4 wheels. Let's say if we made a car, right? That's not true anymore, but some places in India have 3 wheels, right? So, and other places too, even in Greece. They have like a car, it's not really a car, it's like a motorcycle with a cover on it. I don't know. It's kind of weird looking. You ever seen it before, Robert? It's like 3-wheel car. It's like,
it's got a weird bubble on the front.
yeah, that's what it is. It looks like, and they have like a whole little, like a truck body on the back. It's kind of weird, right?
They look very
Yeah, I wouldn't do it, but that's just me, right? But they use them in some other countries. Anyway, so here we have a car class that extends vehicle, and we have the constructor function. Notice that there's a super call here, and this super call is the super class. It's calling the super constructor, which is this one here. So this is what it's doing. So it's saying, so I'm going to extend vehicle. Vehicle is the super class. It has a toString function. This toString function overrides the built-in toString function that's built into JavaScript. All JavaScript classes have a toString function. In fact, all JavaScript objects have a toString function. And so what this is saying is, I want you to override the built-in toString function with my own, right? This is what this is, right? Well, this overrides that one, right? So it's basically saying, hey, if you make it so that it's a vehicle, if it's a car type, then car overrides the vehicle's toString function. And here you can see that it refers to the super constructors or the super classes toString function plus whatever else you want to add, right? Which is interesting that you can add it. Super itself, this super calls the super constructor. That's what this does. And whenever you have constructors that you inherit from in other classes in any other language, you must take care of the super constructor. You must do it. Every language requires it. Okay, this is no different here in JavaScript. Okay. And then down here, you're instantiating an object of type car, right? And you must use the new keyword. That's JavaScript. You must use the new keyword. Swift, no, you don't need the new keyword. In C++, no, you don't need the new keyword in C++ if you're making it if you're allocating memory on the stack. If you're allocating memory on the heap, then you need to use the new keyword. And it's going to be a pointer in C++ compared to something else, right? So the new keyword is not always used, but in C# and in Java, definitely required. JavaScript, definitely required. Okay, you need it. Okay, so I want to talk about this. And then you can use the instance of. Instance of is a keyword where you can say, is the car an instance of the car? And which means it checks to see that the car object, which is this car right here, is an instance of the car class, which is this one up here. And if it's true, it'll return true or false. So this does, okay? So now, why have I talked about this? Because people are very confused about classes in JavaScript. This is JavaScript. This is not TypeScript. So this is the base that we're going to build on with TypeScript. Arrow functions we talked about briefly last week. We said that there are 3 types of functions that I mentioned, right? What 3 types of functions? What are the other 2 types of functions that I mentioned last week? I mentioned 2 more functions last week. Yes, remember? One function was a named function. Remember? My function called start, right, was a named function. And then I had another function type, which was, yeah?
Anonymous.
The anonymous function type, right? So there's 3, this is the 3rd one. So arrow functions, right, not just C#, but they remind me of Lambda functions from other languages, right? Like C#, Java, as well as C++ and other languages like that. And so these Lambda functions, these arrow functions are, like we said, it carries forward the same lexical this as their scope. So please be careful about this. There's positive and negative side effects to this. Okay, that's what this means. And I talked about those side effects. And I gave you some examples here, which I'm not going to talk about right now. This is just for you. JavaScript closures. So this is the idea of a function within a function. And whenever people see this, they always freak out. They're like, wait, function within a function within a function. That's Node.js we're talking about right there, right? And sometimes people call it, function hell, right? Or callback hell, sometimes is what they say. Callback within a callback within a callback. What is a callback? What's the difference between a callback function and a regular function? Is there a difference? You might hear callback function. Right?
So I believe callback is something we use for like when events are triggered or when certain type of event is triggered, make sure you run this patch of code. So
Yep.
that's callback.
Yep. Well, we can make callback functions, right? How do I make a callback function? How do I create a call? I can make my own callback functions. How do I do that? Right, well, I have a function, and then in the function, I actually take a function as a parameter. I can make my own callback function, right? I can call that callback too if I want to, right? And in many ways, that's what we do. When we make a function, we make a function within a function. Here, when I have a function on the outside, this is reminiscent of the IFI that I created last week, the immediately invoked function expression, right? Which basically says anything that I do inside here is locked inside here. Anything that's done in there stays in there, like Vegas, right? Is what I always think, right? Anything that you fool around inside here, it stays in here. One thing to note to note is if you want to expose something from inside of this, you need to return it. So if I wanted to expose child somehow, then I would need to return child. If I had a return statements are the way we expose different pieces of my classes. Okay, I can do that by creating an object. Imagine if I create an object, again, curly braces type of object, a JavaScript object notation, not JSON, but object notation. And I use object notation with curly braces, and in there I create a bunch of properties and I export that. That is a way of exposing whatever I want from within the closure. Otherwise, that closure, it's called a closure because there's nothing none of the stuff that you make in there can escape. Okay? Does that make sense? All right, so we just talked about closures a little bit. I wanted to talk about that because people are freaked out about it and they don't understand what closures are. Okay, so I'm going to move forward. TypeScript. Let's talk about TypeScript. So open source language, it builds on JavaScript by adding static type definitions. This is the thing. And I like this idea of whenever we make a class in JavaScript, we create a shape for that class. Actually, we create a shape for the class. When I say shape, in my mind, I'm thinking memory allocation, right? I allocate memory for that class, right? Here's a question for you guys. General object-oriented programming question for you guys, right? What's fatter? The parent or the children? Parent classes or child classes? What are fatter? Fatter in terms of memory footprint. Child, right? Yeah, see, in real life, parents are fatter. I'm a fat guy, right? So parents are fatter in real life, right? Because we just like, we like to eat, have some barbecue, all that kind of stuff. That's what I think about, right? And but in programming, all languages, children are fatter, memory footprint wise. Why? Because the parent class is nice and slim. It maybe has some functionality, but each child class that derives from the parent class and inherits everything from it adds additional specialization. And if I add anything to the original footprint, then I am fatter. And I'm always going to be fatter. And what this means is if I have a cascade of classes that I inherit from, I have this one class, vehicle, and I inherit car. And then maybe car could have another subclass, let's say something like compact car, or there might be a full-size car, or there might be another type of car, right? Or hybrid, or whatever, right? Those other vehicle classes also inherit from car, and so they're fatter than the car class, and they're even fatter than the parent class, the vehicle class. So every class, every kind of step in the hierarchy chain, I like to call it the chain of command, becomes fatter and fatter and fatter. So why is this bad? And Apple talks about this a lot with their coding standards. They talk about it like it's better to use, I want to use composition over inheritance. What's the difference between composition and inheritance? This is like OOP 101. Right? Composition versus inheritance. Anyone? The three of you? Inheritance, we know what it is, right? Inheritance means that if I have some kind of functions or properties or whatever in my parent class, when I inherit them, I inherit all that stuff. I get all the stuff from my parent, right? That's inheritance. Composition means I compose my class of other objects from other classes, right? I don't inherit. And why that's good is because there's no inheritance chain. And the good thing about composition versus inheritance is if I make changes to this class over here, maybe it'll affect one of my properties, but not the entire class. If I make a change to my parent class, right, it affects my class and all the other classes that inherit from it, like a domino effect.
Because I was thinking more along the line when I said parent, it's more like in, let's say, HTML and you're programming it, you create, and more on the lines of composure.
Yeah. Composition?
Like, composition. Yeah. You're building like your card, right? And you build a bunch of cards, and then you're putting the cards inside, let's say, another div where the parent becomes larger and larger.
Oh, that's
more components rather than the other way around.
Yeah, you're thinking about node-based, kind of parent-child relationships.
Yeah.
Yeah, in that way, yes. In that case, yes. If you're going to use markup, then definitely the more content you add, the bigger the parent becomes. But in this case, for classes, it's like, no, it's the other way around. It's like a class has a very small memory footprint, and we kind of add more functionality to it.
Or even with dimensional arrays, if you take an array that has 5 items and you throw that inside another array, the parent array becomes larger rather than the child array.
In that case, what you're actually saying is, because what you're saying is, you're thinking about arrays as containers, but reality on the back end, it's not like that.
No, it's more like pointers.
Yeah. So what happens is you're actually saying that this array is actually a pointer to this other area. That's all it is. So it's not really that way, right? But I like your thinking because yes, in that case, when it comes to containerization, definitely the container becomes bigger as you add more things to it, which is what you're saying, right? But I'm talking about inheritance. And so when you think about that is the biggest problem we have in modern day programming today with inheritance is that we have so much out there, tech debt, like we said. If you actually starting to program in C#, right? The first thing you program in C# has a ton of things that it inherits from already. It's like massive, it's really big. And some higher level languages than C#, for example, Python, even have more. And if you use a library, let's say, for example, I'm programming I'm making a game with Unity, or I'm doing something with Swift, or Kotlin. Now we're talking lots and lots of inheritance. Like there's a huge amount of library files that are it's kind of included inside everything you do. It makes your job easier, but it's fatter, a lot fatter. It's a lot higher level. And that's the difference between a higher level class and a lower level class, or a lower level programming language. Like C++ to me is probably the lowest you want to go in modern day. Maybe C, maybe you want to go to C, to the C level. But before that, it's like Then above that is C# and Java. I would say they're on the same level, C# and Java, in terms of how high level it is. And then on top of that, now you have Python, Kotlin, Swift.
Even
you know.
Node, when you initialize it, the amount of modules that
Huge.
are like massive. Like
Huge.
If I was doing a .NET program, I wouldn't have to deal with all
You don't know. No, yeah, that's it. It's actually huge. It's more big. It's bigger, right? Right. .NET is massive compared to Node, right? And same thing with PHP, and same thing with a lot of other stuff, right? So, but my point to you is, think about this. Whenever you're starting a program, think about what you're doing. TypeScript also has an overhead. We have to talk about this now because we're talking about TypeScript. Just getting back on track with our what's fatter. Parents definitely in real life fatter, right? But C# in programming, most of the time when I talk about parents-child relationships, I'm talking about child class. But in TypeScript is a problem because TypeScript wraps JavaScript. Everything that TypeScript is JavaScript, and then some, which means that there is some overhead involved, right? However, TypeScript, if we do it right, which is what I want to try and do with you guys, emits or creates, right, really great, succinct JavaScript. So very, very slim JavaScript is what it kind of creates. And perfect JavaScript too, right? Better than you can probably write JavaScript, right? That's what that's what TypeScript does for us. And so that's why it's good to use. And people have debated about it. Why use TypeScript? It's an extra language on top of everything else, and everything else. I'm going to skip here. Talks about a lot of stuff. Here's a little bit of history of JavaScript, of TypeScript. Come back in 2013 when they were thinking about coming up with this stuff. In 2012, they really came up with it. I've been using it for since 2012, I would say. Right when it first released as beta, I was using it because I was dying. I wanted to make a game engine for JavaScript, and I was like, I can't work with JavaScript alone. It's going to kill me, right? I wish there was something object-oriented that they had, right? And at the time, they didn't have. Unity was out there. I could have wrote it with Unity as well, or Unreal, but it was too heavy duty. I wanted to write it native with JavaScript, and I was looking for some language, and that's what drove me to look for TypeScript. I looked it out there, type for JavaScript. And I was like, when is JavaScript going to get types? It's got to have it, right? And people are like, there's a huge community that are against types for JavaScript. They're like, no, we don't want them. We don't want the flexibility that JavaScript gives us. It's a very lightweight model. Vanilla JavaScript, especially now with ECMAScript 2015 and onwards, these are good things. So why do you even bother use TypeScript? Because TypeScript adds more and more functionality that is missing even from today's ECMAScript standards. Eventually, I think they're going to have optional types. I think that's what's going to happen with ECMAScript, my feeling. And one day, TypeScript will be not necessary anymore, right? I don't think it'll be necessary at some point, right? It'll be the point where we don't need it. We're almost there, I would say. We're close to it not being required anymore, all right? But just to kind of talk about language rankings in 2018 to 2020 by GitHub, you can see here that JavaScript was number 1 at the time, Python, Java, and then TypeScript was number 4, right? And the next slide is even interesting because it kind of shows you, this is a recent slide, you see 2022. JavaScript is still number 1, right? And then Python has jumped over here. Java has fallen to number 3, and TypeScript is number 4. C# and C++ is number 5 and 6 respectively, where C++ actually is kind of gone up and down, where it used to be like the number 5 language and then dropped down to C++ and so on. And C# is actually improved as well. So you can see these are the main languages. Other languages, look at PHP. My friend Jeremy is like, I love PHP. PHP is going down, baby, right? It's been going down for a while. Now you can see PHP was one of the biggest languages back in 2014, right? But not anymore. And you're gonna still see PHP drop more and more as things go. And there's a reason for this. And we'll talk about the reason in a second. It's unstructured by default and a bunch of other stuff. But these are the top 10 languages. And TypeScript is number 4. And I think it's going to climb eventually. Whether it's going to overtake Java, I don't know. But because JavaScript is so pervasive in everything that we do, I think that TypeScript eventually will be number 3. We'll see, maybe in a year or two. It depends. Depends on how things go. The more ECMAScript is packed full of stuff, right, you would expect, which it is right now, we'd expect TypeScript to actually fall down in terms of popularity. We don't need it, right? But actually it's just been getting more and more popular, especially over the last 3 years. All right, so that is kind of our map, and this is why I'm telling you, I don't give you stuff typically in my classes unless I think they're absolutely necessary, and I think TypeScript at this point in time in 2023 is absolutely necessary for you to do APIs, in my opinion. And it's a good skill to have. So what about tsconfig.json? What is it? We talked about this last week. It's a configuration file we need for TypeScript. We talked about different compiler options last week really briefly. We said we have module, target, and there's some other things here that have been included that I recommend. No implicit any. What this does is it basically turns off the ability for JavaScript to allow you to, to have an any type. So in TypeScript, this is interesting. TypeScript basically says, if you don't tell me what it is, if this wasn't here, right? This little switch. I call these all switches, right? Do you turn the switch on or turn the switch off, right? These switches that are inside of our compiler options basically turn on the switch that says we're not going to accept any implicit returns, right? Which means things like any. TypeScript will say, if I don't know what it is, if you haven't told me as a developer what this is, I'm going to assume it's an any type. Any type means I'm not going to use TypeScript. I'm just going to go back to JavaScript. It could be anything, right? And sometimes, I have to tell you, it solves my problems by kind of like flagging something as any. I don't know what this is, guys. Let's make it any for now. Move on, right? And you'll see me doing it. We'll do it probably this semester for sure, 100%. We'll have something as any because we just can't figure it out, right? Hopefully we won't. But remove comments. I don't want to carry the comments that I'm doing on the developer side to the actual code. Remember that code because we're using it in the browser, the slimmer the code is with no separation, especially if we micronize it, if we compress the code and make it all look like a big block of code, it actually makes things run faster because the browser, what it does is it's an interpreter, and the browser will go through and it'll look at every single line, every single space, and the more it has to look through, the longer it does its search, right? And so it takes longer for things to load. So for years now, we've been compressing our JavaScript files and our CSS files and our pictures and a bunch of other stuff, images, and so that they're super small. Even our HTML can be compressed, right? Because the browser will try and look through all of it, right? So here we want to definitely remove comments. Source maps are true. We said this last week. This is a review because we want to be able to do troubleshooting. So I can look at lines on the TypeScript side, and it'll actually report out what my problem is on the TypeScript file. I'm not programming in JavaScript. I'm using TypeScript. So I don't want it to program. I don't want it to point to my JavaScript lines, and I'm going to go, oh damn, I have to pull up both files and go, oh, which one is it? Oh, it's this one, right? And sometimes it doesn't even translate one-to-one because I'm emitting JavaScript from my TypeScript. TypeScript will be nice and beautiful, and then JavaScript will be like compressed. And I'll look at it and going, oh, I don't know where this is, right? So I want it to be pointing to TypeScript, and that's why source maps must be true. That's why I did this config with you last week. We just didn't include these two pieces. They're not required. They're options, but I think they're good. And there's going to be many more options we're going to include here. Many more, right? Okay. Let's move on. TypeScript in Visual Studio Code, we talked about this. So you can put the TSC command in last week, or you can press Control-Shift-B or Command-Shift-B on the Mac, and it will transpile. It will create almost like this little task runner inside Visual Studio Code, and the task runner will allow you to do a watch task, create a watch task. And creating a watch task will basically, if anything changes, one of the biggest complaints with TypeScript is, well, I didn't realize it, but I'm not transpiling. Okay, I'm not realizing it, but it's not transpiling. And if you add that to Node, well, I didn't realize it, but I forgot to reload my my server. I made a change to the server. It's a problem with Node, right? Remember? If I don't change my server, remember what the server does in Node. We're going to talk about it today a little bit more. When I create a server in Node, I create an object. Once that object's been created, that's what the server is an object. If I've made that object, it can't be modified. It's immutable. It's an object, right? If I modify my server again and I don't reload it, it doesn't matter. I can modify it all I want. And because that object is still active and alive, right, it's going to run the old way. So the other second complaint we get is, well, I made changes, I transpiled, but my server, nothing happened. The server is the same. Well, because you didn't restart your server. That's why we use NodeMon. NodeMon watches for changes, and then restarts the server, because that's how we develop stuff with Node.js. Right? So just mentioning these things are possible issues when it comes to programming backend stuff. Okay, and this is the example of how to do that. One thing that says is browsers only recognize JS, but so too does Node. Node only recognizes JS. It doesn't recognize TS, which we'll see in a bit. Okay. Let's talk about Node.js a little bit. Back in 2009 is when it came out of. We talked about this briefly. Starting in 2008, we looked at this, kind of this brand new V8 engine from our friends from Chrome, from browser, the Google people, now called Alphabet. And, they made this really beautiful thing. And Ryan Dahl, right, he was this dude that came up in JS Conference EU 2009 and said, hey, I want to make this project called Node.js. But recently, after that, they had a bit of a schism, right? And I have to talk about this, where there was a whole other project that was being run with Node.js. At the time, Node.js was like 0.14, 0.15, 0.16, 0.18, right? We're like, wow, what are you running? I'm running 0.16, right? And then all of a sudden, when everything came together and they made up, these two big committees. When people, we don't like the way your node is going over here. We don't like the way you're doing over here. They came together and they made the brand new version of Node.js, and then Node jumped from like 0.818 to 4. That's what it jumped to. And it happened overnight. Like, it was really weird. 2015 was a huge year, and when we went to like this, next version of Node, or 2016, one thing that Node is known for is this idea of non-blocking sockets. And there was always a kind of a concern of how it could be worked, how could it work properly, and so on. And Node.js, we know, is event-driven, right? Whereas PHP is not event-driven, right? PHP is actually multiple sockets that it produces, one for every time a user goes on a PHP server, it creates another socket, creates another port, basically, another duplicate of itself, right? Because it's multi-threaded, right? Whereas Node.js is single-threaded. Okay, so this is kind of weird. And what it does, because Node.js is event-driven, right? They figured out that multi-threading actually has a bunch of disadvantages, some overhead into it as well. And so if you look at it, here is an example of Apache, which Apache runs PHP, and you can see that's the kind of the teal, kind of surface right here, this area down here. And then this area up here is Node, right? Nginx is how you pronounce that. And when you're running Nginx on a Linux server or something like that, you can see that depending on the request per second, right, Node stays fairly, good. It doesn't matter how many requests per second you give it. Why? It uses a single-threaded approach, right? And it uses that whole request response idea that we talked about earlier. That REST kind of it's kind of a REST system. It supports REST out of the box, right? And so what it does is it basically says, I'm going to prioritize each of the responses in order, the order that I get them in. And Node can actually maintain a bunch of concurrent connections for much better than PHP. You can see how the performance of PHP goes down as the number of concurrent connections increase, right? And this one is a real telling one, which is the blue is Apache, and this is memory utilization, right? And you can see Node stays exactly the same. And this is where these two pictures is the thing that I would tell my friend Jeremy, PHP is going to be a dying beast, because eventually, right, the more data, especially with big data and everything else we're getting out there right now, it can't be sustained. Even though the latest versions of PHP are better than this, right? They've improved their multi-threading environment, right? It's still the same problem. So memory consumption-wise, because we only have one thread, it's flat, right? Whereas the more and more users that come on board, more concurrent connections, the more and more memory PHP requires, right? And this is where you have a busy holiday season, Christmas, Easter, all those things, Black Friday, Cyber Monday, and then some places go down because they're using PHP on the back end or some other type of service, not Node, right? Even IIS, Microsoft's version of, PHP or whatever. is the same thing. It's a multi-threaded environment, right? So, most companies offer now, or most cloud services offer a Nginx environment for the most modern servers. And what we're going to do in this semester is, of course, we're going to use Node, and we're steering away from PHP and all that stuff. Not because we couldn't do this course in PHP using creating an API with PHP. I don't think it's a negative thing to learn. We just want to learn about it here. Okay. So this is kind of important information. One thing is also Node.js includes a lot of core modules that are pre-bundled. So now going back to what you said, with a bunch of NPM modules we have to download to enhance Node.js. Let's take a look at Node.js for a second, just really quickly, right? So if I go to nodejs.org, and if I go to docs, let's go there. And if you look at the latest version, let's say version 20 of the API, right? You can see that if I look at my core modules, right? There's a lot, right? So for example, HTTP and the file system, these are modules that are bundled along. This is all the stuff that's bundled along with Node.js. However, you have to activate them. So if I want to use file system module, then I need to say something like import file system from Node.js, right, or whatever. If I don't do that, or if I don't require, in the old system, if I don't require FS, right, then I don't use file system. It's as slim or as fat as you want to make it, as you need to make it. That's what Node.js does for us. It has a lot of stuff that's built in now, and they continue to bundle more and more things that make sense with it. However, it's all optional. You can turn it off or on, okay? Just FYI. So back to this, lots of core modules. And again, the old way of doing it is require, where you would do something like const file system is equal to require file system. That's activating the file system module, right? That's the way to do it. And then we can also use, Express. Express is a third-party module. What Express does for us is it extends the Node core modules and adds a lot of little functionality that is very commonly used, right? That's why Express is so popular. Express is built upon other stuff, right? That's been made over the years with Node. And by the way, at one point in time, every module had its own package manager, had its own package.json, and its own modules bundled inside of it. Okay, now, you think we have a lot of functions and files now. Back in the day, if I had 30 NPM modules, each of those modules depended on other modules. Those modules would be inside of those modules, and those modules would be inside of those modules. And so we would duplicate modules within modules within modules. And I'm talking about the average little site that I would come up with would have 30 to 50,000 files. And most of them, 90% of them, were duplicates. That's what they were at the time. Latest version of Node.js, what it does, of course, is it only includes one copy of the module that you need. All the dependencies only have one single copy, and so it reduces 90% of the noise that we had back in the day. Node modules. So again, this is the old way of doing things. We use the require, right, to do it. Here we would use import, and the way how would we write this differently in ECMAScript module pattern? We would say import hello from /modules hello. That's the only difference that would be. Import hello from, okay? And that's what this module pattern does, okay? Very, very simple way of doing things, okay? So let's just keep going here. So Connect was kind of a module that had a lot of stuff that improved Node by a huge amount. Like Connect was amazing, right? When it first came out. And Express builds on top of Connect. That's what it does. So it actually extends Connect, this module Connect. We don't use Connect anymore. I don't know if you ever see Connect included anywhere. No. Express does all that work for you, right? But it used to be Connect. And this is an example of a simple web server using Node. We're going to get to that in a bit. And what this does is it says, hey, we want to make a little HTTP server, and notice that it has up here. Now this is the key learnings here. We have the request and the response. Question, do we use the request object here in this code? Do we use the request object here at all? No, right? We only use the response object. Second question, what if I have multiple files that I want to look at, right? If I write a little server of my own, right? And each file has its own CSS and each file has its own JavaScript, right? How many times do I do that request response? How many times do I do that round trip to the server? So example, I have a file, home or index.html. And that index.html file, I'm talking about this with you guys because I want you guys to understand the system, right? We could do Visual Studio Code, but it's going to waste our time because we want to get to the Express stuff, right? So think about this now. I have an index.html. It has CSS, and it also has one or more JavaScript files. Let's say 4 JavaScript files that are connected to it. How many requests did that index.html do to the make to the server itself? How many?
Every request for each file is called.
Every request for each file is right. Now, once you think about this, what it does, every time it goes out to the server, right, it uses that new file as a request. It requests that file from the server, and then the server will interpret that file and attach a MIME type. What type of file is this? Is it a JavaScript file? Is it an HTML file? Is it a JSON file? What is this thing, right? Every single time it'll do this round trip out to the server. And that's what it does. That's what these things do. Whenever we do a request response here, and you have files that are written on Node.js, it does all this kind of round trip stuff. Whenever we do a round trip, it's much slower than if it's done on the client side, right? That's why we have this whole revolution of client side. JavaScript is so important, and blah blah blah, and that's why we have client side frameworks like Angular and React, right? Client side means before we go do a round trip with the server, we deal with it locally with our client side JavaScript, no server, right? That's why I said there's whenever we validate stuff, there's 3 levels of validation. We validate first on the client side, then we validate secondly on the back end, and the third type we do is in the database, right? So we do 3 levels of validation. Okay, so that's kind of what Node.js applications look. We initialize things by using the node keyword, but we're not going to do that. We usually bundle things in some kind of script, like run, and we do it that way, okay? So here's an example of serving static files. And I want to mention this because now here's an example of the old school way of using the file system. Here's our file system module. This is the core module built into to Node. There's nothing for us to look. We don't even need a package.json file that includes anything because the FS module and the HTTP module is included in Node, right? And now we have some interesting stuff where we have this stuff here, __ dir_name. What is __ dir_name? You guys see it. You've seen it in Express. What is it? Yeah, Darrow.
Get the current directory.
What is it?
Get the current directory.
Okay, but you know what it really is? It's a global. It's global and it's built into the file system module. Whenever we use dir_name, that is going to be a global return type. It actually holds the global address of our directory, right? So __ dir_name is a variable that exists as long as we include the file system module, right? And that's what it says here, file system.read file dir_name plus, here's the request URL, the URL that's part of the request that we put in here, right? That is the name of the file. Take a look at that. The directory name plus the requested URL, which is index.html as an example, okay? That's what it is. And then we have a callback function. And this callback function, that's what it is, or inline callback function, is all the way down to here. That's what this does, right? And this callback function triggers when the server gets a request that includes some kind of index.html or whatever, any kind of request actually, right? This will trigger this function here. That's what it does. And then it's going to say something like, hey, do I have an error? If I have an error that comes back, because the function has 2 parameters, error and the data. This is the buffer from the browser. The browser itself has a buffer, and the buffer includes everything that's inside of your index.html file or whatever you're requesting to read from, right? That's the data. But if we get an error, this could be a server error. Like, for example, file not found, right? If we get a file not found, we want to write out, we use something called write head. So the response object, we look at the write head method, and we write out the status code, which is 404. 404, the reason why it stands for file not found is because 4 starts with the letter F, and 0 in British is not, right? So file not found, 4 not 4, right? That's where it came from. All the status codes came from some developer that had some humor involved, right? And a little bit of some thinking involved. This is where they came from, right? 4 not 4, or file not found, right? And file not found to me, whenever I see this, is because that's probably the only error you're going to get in this case when I read a file, because I'm reading a file. That's what I'm saying. File system, it says, go read a file. Use this read file method. Read this file, the file that I'm going to look at from whatever the request gave me. But what if there is no file that's named index.html? I'm going to return a 404, and I'm also going to JSON.stringify the error, which means it's going to come out in JSON format, right? That's what it's going to look like. This return, right, this return is actually, if you think about it, is going to return from this function. That's what it does. And so this return, it actually returns out of this function, right, and it stops. But we also have two other little response write heads. So this one is if there's an error, right? But if there's no error, right, then it's going to return a 200. A 200 means everything's okay. That's what it means, right? That's a 200 code. What about 304? What does that mean? There's some basic codes you should know, all right? 200 means everything is okay. 304? Nothing has changed. That's what 304 means. Everything's the same. You've requested the same CSS file. We've cached it. Thank you very much. We don't need anything else, right? How about 401? What's a 401 error? We're going to get to that this semester. It means unauthorized, right? That's what it means. You've asked me for a file. I have it, but you're not authorized to use it. 401. That's what it means, right? 500 is a server error. We never want to see that. That's like your server's down, right? Or something like that. 500, right? And there are others, but the biggest ones that you want to think about always are 404, 200s, 401s, and 500s. Those are the ones you need. Anything beyond that, right, there are going to be other extraneous errors we're going to see. And then notice that we're using something called function chaining here, right? So this part up to here, right, it actually creates a function. This is the function. Right? It returns the server. It creates a server object. That's what it does. And then once it returns the server object, because that's what create server does, it makes a server object. It's immutable. As soon as I make the server object, it's made forever, right? I can't change it unless I stop the server. But once I've made the server object, then I can do a listen on it. I can listen on port 8080. That's what this does. So this whole thing is the back end for how Node.js will work. It doesn't matter, right? And that's, things that we've already seen before. I'm going through this in detail because I want you guys to understand, because some people will just accept it. You just kind of look at a bunch of code, you're like, well, I don't know what that does, but we need it for some reason, right? No. This is not that kind of class. This class, we're going to know how to use all of it and understand it all. I'm hoping by the end of this class, it'll clear up some of that confusion. Questions around this so far? I know it might be confusing, but we're going to see some of this later on, and hopefully you'll tap into it a little bit. This is more of a complete example. So here I've just given you a complete example the old way, right? And what I've also done is use the path, and MIME types. This is a third-party module called MIME types. I'm just going to zoom in here, right? So I've used 3 modules built in, HTTP, URL, and the FS module. These are all built-in modules here when I wrote this, right? And then we have, I'm also requiring here, right? You can see that I'm requiring MIME types. MIME types is a third-party module that basically describes or figures out the type of the file, because the biggest problem we have with the static file server is like, what kind of file is this? Is this a HTML file? Is this a CSS file? Is it a JavaScript file? What if the JavaScript file accesses another JavaScript file? That's another request, right? If the JavaScript file is also has event handling in it, it generates other requests, right, for the server sometimes too. There's all kinds of stuff that can happen. So that's why we did it this way, right? And if you look through here, that's what path does. Path basically takes the parsed URL, and the parsed URL uses the URL module. That's what this does. It's the URL module, which takes the requested URL and combines it to create a parsed URL. All right. So the reason why you would want to do this is so that way you clean up the thing that the user has made. If you actually look at the request object, incoming from every request from we'll see this later on. It's massive. The request object is huge. It's going to take up pages and pages of data. That's how much it's built into the request object. Same thing with the response object. It's huge. So we want to parse it. We want to make it smaller, and that's what we've done here. Okay. Same idea, but now we're actually we're using MIME, which is a library to look up the path. And the path lookup basically says, take a look at this path. What is it? And then determine whatever the MIME type is. So this write head, what it does is it writes out the MIME type as a header for the browser. Again, this is us writing directly to the browser to let it know what we want to do. Okay, guys, we'll never have to do this. Okay, I'm showing you this code so you understand the back end of what it looks like to write things in Node.js, but we're never going to get to this level of granularity because we have Express. Express takes care of all of this for us. It takes care of the MIME type, and it also creates a view engine if you want it as well, like we saw last week with the EJS view engine. Okay. We're sitting at 9:51, and I've pretty gone for a good while. I think it's a great time to take a break, and when we come back, we'll finish off with Express and do a little demo again about Express in more detail, and let's see if we can add TypeScript to our Express. Okay, I'll stop recording now. No problem. Let's take 10 minutes. Let's be back at 10.